Hey everybody, how we doing? Welcome to CoreOS Fest 2016, San Francisco edition. Satellite event, if you like. Give me just a moment to get logged in. I have some lovely slides to show you. All right. So once again, welcome everyone to CoreOS Fest San Francisco, our satellite event. I know some of you have seen the keynote speeches from the Berlin version of the show in the overflow room this morning. If I recover any of that, I apologize to those of you who paid very close attention, but I am going to hit some of the same highlights as our CTO, Brandon Phillips, hit in his keynote speech in Berlin. Largely what I want to do is kind of tell you the story of what's gone on in the last year since our last CoreOS Fest, a little bit of a summary, and kind of hit the highlights of some of the newest things that we are either announcing today or have announced very recently. Before I dive into that, I'm going to talk just for a few moments about the kind of background of CoreOS and our overall mission, which is, as I'm sure you're very used to hearing by this point, to secure the internet. As I like to phrase it, because it makes it a bit more specific, and I am the documentation writer on staff, we're really trying to secure the infrastructure that powers the internet. We are obviously less concerned with front-end and user interface technologies and more concerned with delivering automation and orchestration in the server and container cluster space. How do we do that? Well, that's what this conference is all about. We've thrown this conference now for 2 years to celebrate, mark, and thank our open source contributors and to tell you the latest news about the things we're developing that are not only in pursuit of our commercial platforms like Tectonic, but a set of composable modular tools from which platform builders and infrastructure builders can assemble their own toolkits and pursue their own solutions. Over the course of the last year and throughout the lifetime of CoreOS and our many open source projects, thousands of open source developers, community contributors have contributed across the board to those projects. Many of you are here today or are with us in Berlin. We extend our warmest thanks to all of you and very much appreciate the feedback and effort that you join with us in creating all of these things. We continue to look forward to working with all of you in the future, and in some of the points through this brief introductory talk, I will be trying to point to some areas where we think help would be very welcome, and it might be neat places for new contributors to get involved and get an introduction to sort of the open source DAO, if you will. Last but not least, I wish to thank everybody on the CoreOS staff and event staff who have helped us put on these two quite large-scale events at great geographic disparity from one another this morning in Berlin and here today in San Francisco, and all the folks from our New York office who are joining us here, some of whom are speakers or answering questions in the audience from the Quay team in New York. So, let's get to the stuff that you're probably actually interested in. One of the fun things about this conference, CoreOS Fest, is that it is an open source and mostly non-commercial conference. So instead of talking in high-level summaries about how our products and projects fit together into these platforms that we are at the top of the line trying to assemble, we actually get to break out and talk about each of those component parts. And from the introduction in my talk into deeper and deeper details through the talks that will follow this one today. So first up, we have a brand new version, a beta version of etcd, which is our distributed key value store that lies at the heart of many popular open source projects, not least of which Kubernetes, that we will obviously hear our keynote speaker talk about here in a few minutes. etcd has seen wide adoption across the container cluster infrastructure space and throughout open source distributed computing as it evolves in what we might think of as the cloud computing or commodity computing era. etcd3, this new beta aims to make etcd more efficient in its usage of memory, improve etcd's performance as it scales to many more nodes and manages data for clusters of larger and larger sizes. Pursue that, in pursuit of that scalability, we have subjected etcd to a number of punishing functional tests. At first, this maybe made etcd a little bit sad, but the work in the etcd3 beta has helped make it quite a bit happier. How do we do that? etcd3 has adopted a gRPC-based API. It's about 4 times faster than the etcd2 JSON-based API transactions. HTTP2 improves efficiency through binary package or packing at the HTTP layer. We've also created a brand new disk or permanent storage engine for etcd. Now scales easily to gigabytes of data managed for a distributed computing arrangement. We've made not only improved the performance and made etcd faster, we've also made etcd more consistent in how it performs at scale and more linear in that scaling so that it is more predictable as you add more nodes, more clients, and more transactions to the etcd cluster. Part of that work in improving the overall consistency of etcd performance has concentrated on how snapshots are implemented that maintain a permanent record and a restorable record of cluster state. In the past, a snapshot could cause a sort of pause in transaction processing. Snapshots are now made incrementally across the lifetime of an etcd cluster so that the individual impact on transactional performance for the clients that are reading and writing data, doing the important work in the cluster, is much reduced during snapshot times. This is similar to improvements in, say, garbage collector performance and controlling when the sweep happens, or in our case, when these incremental backups and flushes to disk happen. The top line of all of that is that etcd3 will support Kubernetes as its primary distributed key value store as Kubernetes scales to 5,000 nodes and beyond in the future, which is a subject of intense work and design discussion in the Kubernetes repositories at this time. So etcd will be a part of that. There is a beta available today at this URL. Our GitHub repos are pretty easy to figure out. They're all under an organization called CoreOS and named by the project name. So you can find etcd3 betas for your development testing purposes. And we will be seeing an official release of that in the software near future. So I don't have a promise date for you, but it'll be real soon now. And we encourage you all to test it, try it out, file issues, and pull requests against the evolving etcd3 API and binary client. So moving on from etcd into some of the other things we'll hear about today and have heard about in Berlin. Some of you are probably familiar with Quay, our container registry. Quay is a commercial product, but like so many of the commercial products we build at CoreOS, has a large farm team of open source work leading into it, and these open source projects do form components that are reusable outside of the scope of our commercial projects. So I obviously encourage you to sign up and try Quay, but Claire is of interest to anyone who is developing in the container space, and I will try to tell you a little bit about why. First of all, actually, I stumbled there and said the word Claire, which is what we're going to talk about just after this. First, we're going to talk about improvements to how we actually pull and download images from the Quay repository, and that all revolves around a tool we call Quay Cuddle. Quay Cuddle adds flexibility to how images can be pulled from a container registry, and of course it starts its support with the Quay container registry. From the Docker world and the Docker container image, we're all probably fairly familiar with the idea of packaging container images in layers. This is very convenient on disk, where it allows you to construct sort of cyclical graphs of changes between those layers, like any sort of snapshot system would do. However, this can be a little bit chubby on the wire. So one of the things we see is that there are a lot of large containers in the world, container images in the world, and pulling them to a large number of machines in our modern container clusters can be somewhat painful. I mean, here we're looking at about 120 megabytes of total layers. One of the things that Quay Cuddle implements is a different style of pulling a layered image from a repository in a squashed form to reduce its space on the wire. So this is what a squashed pull looks like using the same image, and we can see that in many of these images we see up to a 50% reduction in the size on the wire when we're moving them with the Quay Cuddle tool in this squashed form rather than in their layered form and fetching them one layer at a time in the traditional sort of Docker container image method. The second thing we can do with Quay Cuddle is perhaps even more technically interesting, and that is use the BitTorrent protocol to distribute these somewhat large container images. It's going to be highly efficient inside of container clusters because the machines in the cluster are able to share pieces of a binary and don't have to each download the entire container image that we're trying to run and execute on that cluster. Quay Cuddle, also brand new code available today in its Git repository in the CoreOS organization. Another thing we encourage you to check out and offer us feedback on. A couple of more open source things about Claire. JWT Proxy is a new service-to-service authentication mechanism that we have created in support of a security scanning system we have written to scan container images stored in the Quay repository. That security scanner is called Claire and is itself an open source project, even though it is part of and provides a very important service to the Quay commercial project. Now, what Claire is all about is sorry, I advanced the slide too early there. What Claire is all about is scanning static container images in the repository without executing them and without scanning them repeated times as new vulnerabilities are discovered. It maintains an index of a container as it's uploaded, has knowledge of the packages contained in each layer of that container, and is able to map those packages in those layers to known vulnerabilities in the upstream operating system's distribution of those packages. Ghost is a really familiar security vulnerability we've seen in secure shell libraries in the last 18 months or so. Claire is designed to ferret these things out in your container images and moreover offer you remediation or amelioration paths by giving you links to the upgraded package that would correct the security vulnerability as it exists in a layer in your container images. Now, JWT Proxy is interesting in that it is an abstract mechanism for authenticating one service to another. Quay, we know that the Claire service is the Claire service we intended to run, holds the token that gives it access to the cluster of Quay machines that are actually running the registry software. A few highlights about it. It's actually built on top of well-known protocols and is a really simple proxy layer that's compatible with TLS infrastructure, can get through load balancers, and doesn't have some of the other, sort of common failings we would see at implementing a proxy like this for authentication at a lower level of the network stack. JWT Proxy, also open source software available today. We encourage you to check it out, and especially with this one, this may be interesting for integration in your own projects that require service-to-service, or as we might rather say today, microservice-to-microservice authentication. So once again, under the CoreOS organization, there is an open source repository of this code that we encourage you to take a look at. One last note on Claire and why you ought to check Quay out and these two tools. A recent scan of all of there are millions of container images stored at Quay from a variety of developers at a variety of skill levels and security concern levels. When we scanned a sample set of those container images recently, we found that about 66% of them still contain this ghost vulnerability that is, at this point, a fairly old and well-known vulnerability. But packages in large operating system base images live on in containers, and that is exactly the problem Claire is designed to solve, and JWT Proxy exists in support of solving that problem. This is sort of what it looks like in the Quay UI, a rundown of vulnerabilities within a container. And Quay does offer free developer accounts for individuals with public repositories, so this is a very easy way to start getting some kind of line on security scanning of your existing container images. And that's where you can find out more about that. All right. The last thing I want to touch on is something I never give a talk without talking a little bit about. It's very close to my heart and to the work I do at CoreOS. And that is what I like to think of as a global shipping standard, a real industry-wide standard for what a container image is, what it means, how it's defined. How long is it? How tall is it? How many of them can you stack in a row? In pursuit of that, there has been a bunch of interesting work over the last year, both in our own originated AppC project that developed an image specification called ACI, the Application Container Image, and in continuing improvements to the Docker image format, which is now at version 2.2 and has, we feel both of those projects have fed innovation in the other. Certainly anybody who does containers watches what Docker does and is influenced by some of their design decisions in one direction or another. And certainly the Docker image format has, over the course of AppC's lifetime, picked up some of the things that we think of as AppC's highlight features. We're very pleased to be able to say over the last couple of months that this work is beginning to be unified under the auspices of the Open Container Initiative, which is an industry-wide open source, open standard project that involves ourselves, Docker, Red Hat, many other players, major players in the container cluster infrastructure space, to drive a real and implementable container image standard that everybody can implement to get portable containers that can be run on a variety of infrastructure without rebuilds, and to allow the choice of container engine and underlying cluster infrastructure to be more and more an economic rather than a technical one. We think a portable container image is absolutely essential to that effort, and is in fact the keystone and foundational piece of it. So the work that has been happening at OCI to establish that standard is very exciting for us, and we're super happy to have everybody on board. And it's yet another thing that we really encourage you to come out to the repos, take a look at, offer your opinions, your advice, your experiences with constructing container images and what they ought to look like in a standard format that the industry can adopt, and that will become something we hope like IETF standards for the internet that allow interoperability among competing and mutually innovative partners / competitors, right? So, and these slides will be available if you're not memorizing these URLs, although you will do very poorly in the quiz I'm going to give you afterwards. But they will be available for you guys to check these URLs afterwards if you're interested in this project. Last but certainly not least, I'm going to talk about Rocket, our container runtime engine. Rocket really originated in pursuit of that same goal that you see happening at the OCI project. The idea of Rocket is not so much to replace any existing container engine, but to drive the adoption of a portable container that it could share with those other alternate container engines. Rocket is implemented along lines of modern security best practices, enforces offline image signing with GPG keys rather than a server-based signature system. We feel like that's a little bit more reliable in the kind of deployments we see, and those are one of the problems we were trying to address. Rocket does not implement a monolithic long-running daemon process that is intersposed between your system control utilities or init systems or service management systems and the applications running in your application containers. It makes it much easier to integrate with init tools like systemd, which makes it considerably easier and makes the API well known for how cluster orchestration and other management systems can instantiate containers running under the Rocket engine, and more importantly, manage their complete life cycle, restart them when they fail, and restart them during rolling upgrade scenarios, because systemd or whatever init system has much more knowledge about in-container processes, and they look a lot more like standard Unix processes that can be managed by standard system handles when they're running under Rocket. Rocket currently supports our own application container image format, the Docker image format as well, and converts and runs Docker images on the fly. And as the OCI image specification becomes an implementable thing and is fleshed out in reality under the OCI project, Rocket will offer first-class support for OCI as well. Currently, Rocket is at version 1.5, and probably one of the most exciting things about it to our friends in the open source community is that it is currently an alternate container engine in development repos in the Kubernetes project, and we anticipate and are trying very hard to make sure that it is a supported alternate container engine by Kubernetes 1.3. And we think that'll be very interesting because it'll allow people running these sorts of clusters to choose their container engine based on environmental concerns or security concerns or other concerns about fitting their container management tools in with other tools in their common set of operations or common corporate policies. So we think that work is very cool, and we're very excited to see that. Something like 92% of the E2E tests in Kubernetes pass with Rocket as the container runtime right now today. So that work is actually quite close. So that's a little overview of what I think of as the highlights, and you'll be hearing some more about that stuff from our speakers later in the afternoon. Once again, I thank you all for your attention and for coming out, and let's keep building our industry towards production, scale, and security.